Hello students, welcome to Get Metallurgy MT YouTube channel. In this new video, under Learn Concepts Through Problem, we will understand the concept behind solving linear and non-linear algebraic equation through numerical methods and solve the questions of Get Metallurgy previous year question. So let's get started. Numerical methods. Numerical method is a mathematical tool designed to find the approximate solution whose exact solution can't be determined. Mainly, there are two types of algebraic equation. First one is linear algebraic equation and second one is non-linear algebraic equation. These equation forms a straight line on graph and have fixed slope, whereas in case of non-linear algebraic equation they forms curve on graph and variable slope. Linear algebraic equation further can be divided into two parts. One is direct method and other is iterative method. In direct method we study Gauss elimination, LU decomposition method. In case of iterative method, we study Jacobi method, Gauss-Seidel method. In case of non-linear algebraic equation, this is method for finding roots for single variable equation. Under this, the methods are bisection method, Newton-Raphson, secant method, regula-falsi method, fixed point iteration method. These are names of few methods. There are more methods under all this for solving this type of algebraic equation. In our syllabus, we have to study these three: bisection, Newton-Raphson and secant method. So we will start with bisection method. This method applies for non-linear algebraic equation which is continuous function fx in the closed interval ab that approximates the value of the function assuming at midpoint of the straight line connecting the curve between interval a and b with fa and fb are opposite sign function value. So now we will understand this with the help of diagram. Suppose that we have this graph that goes something like this. Suppose that this is fx and we have interval here, a point on the x-axis and other point b on the x-axis, and this value is fb and this value is fa. Bisection method we can apply only when fa into fb is less than 0, means function's value on the either of the side is negative, so that the product is negative, and it makes sense because then only the curve crosses this x-axis here and we will be able to find a solution here. Now according to bisection method, it will draw a straight line between the a and the b point and the midpoint the new root which is closer to the real root of the equation. So x is defined as a plus b by 2. So now we will understand this method with the help of example. Let the function fx equal to x cube minus 4x minus 9 equal to 0. We have to solve using bisection method up to third iteration. In case of bisection method, you will notice that the interval is not given here. So there are two possibilities. Either the interval is given in the question or we have to determine this by hit and trial. So we will start with 0. F of x equal to 0 is 0 cube minus 4 into 0 minus 9. So it will be minus 9, which is a negative value. Now we will try with x equals to 1. It will be 1 cube minus 4 into 1 minus 9. This will be minus 12. So this is again negative. F of x equal to 2, we will get 2 cube minus 4 into 2 minus 9. We will get minus 9, which is also negative. Now we will try for x equal to 3. 3 cube minus 4 into 3 minus 9. Now we will get plus 6, which is a positive. So we will stop here. So we will take two initial values are. So our A will be 2 and B will be 3. Now we will check the necessary condition. F of A into f of B should be less than 0. F of A, that is 2, is given as minus 9 into f of B, that is x equal to 3, is given as plus 6. So it will be minus 54. It is less than 0. This satisfies the condition. Now we can determine the value of first iteration. First iteration, x1 equal to a plus b by 2. It will be 2 plus 3 by 2, that is 2.5. Now we will draw a number line. In every question, whenever we will be solving a question by bisection method, we will draw a straight line for number representation. We will start with boundary condition as interval as 2 and here 3. F of 2, we have minus 9, which is negative number, and f of 3, which is a 6, which is a positive number. So root will lie in between, and that will lie at the midpoint. That is the first iteration value, x1 equal to 2.5. Now we will determine f of x1. F of x1 equal to 2.5 cube minus 4 into 2.5 minus 9. It will be minus 3.375, which is a negative number. So now from this we can easily see that the next iteration values will always lie between the one negative value and one positive value. So we will proceed with the next iteration value. Second iteration, x2 equals to, now we will write x1, which is 2.5 plus b value divided by 2. So we will get 2.5 plus 3 by 2, which is 2.75. Now we will determine the value of the function. So f of x2 equal to f of 2.75. It will be 2.75 cube minus 4 into 2.75 minus 9. So this value we will get plus 0.79685. So the next value, we have got the midpoint here, and this value is coming to be positive value. This is x2. Now again we know that the next iteration value will lie between a negative function value and a positive function value. So next root lie here, not here. x3 we will calculate here. So moving to the next iteration value, that is third iteration. x3 equal to, we will take in between this. So first one will be this, second one will be this. So x1 plus x2 by 2. So we will get 2.5 plus x2 is 2.75 divided by 2. So it will be 2.625. Now we will check the value of the function f of x3. It will be 2.625 cube minus 4 into 2.625 minus 9. Now we will get minus 1.412, which is a negative value here. So we know this one is negative value. Again we know that from our concept that the next iterative root value lie between one negative and one positive. So this will not lie in this. So it will lie somewhere here. So now we have calculated up to third iteration. So our answer would be 2.625. But our main motto was to understand the concept. For the bisection, we have to understand that fx we have taken x cube minus 4x minus 9. From looking at the equation, we can say that this equation has 3 roots. By solving this equation by bisection method, we will always be getting only one solution, and that depends on the interval we choose. Suppose that this equation has a graph something like this. So it has 3 roots. This one here, this one here, and this one here. If we have taken the initial guess between this and this, then we will be able to get to the only this answer, x3. We will be able to get to only this answer. If our guess was between these two, then we will proceed to this answer. If our guess was between this, we have got this answer. But we will converge to only one of the roots. That depends on the initial guess or the interval we have taken. The order of convergence is 1 because we choose a straight line. Now we will solve 5-6 questions from this topic to understand the concept more deeply. Then we will proceed to the next method. So first question is, which of the following is a direct numerical method? We have seen that this is for non-linear algebraic equation where the slope is variable. This one is a linear algebraic equation and this one is direct. This one is direct method. Along with this, we have studied one more direct method, that is LU decomposition method. We have studied bisection and secant in case of non-linear algebraic equation similar to first one, Newton-Raphson. So for our question, option B is correct, Gauss elimination, which is a direct method. Second question is, what is the primary purpose of numerical methods? We have seen during the introduction that primary purpose of numerical method is to find the approximate solution to the mathematical problems. So option B is correct. For this type of question, we do not proceed through symbolic or analytical or theoretical because solution through all this will be either complicated or very lengthy to solve to exact value. So we proceed to find approximate solution to the mathematical problems. Next question is, which method is best suited for solving non-linear equation? So now we will recall what we have studied in the first slide. In the first slide, we have studied these methods. So we can see that for solving non-linear equation, we have here and we have following method like bisection, Newton-Raphson, secant, regular Farsi, fixed iteration. So in the question, Newton-Raphson is given, so this is correct. Whereas we can see LU decomposition is direct method. Here Jacobi is here iterative method. For linear solution, also Gauss elimination is here direct method under linear. So only non-linear is Newton-Raphson. The next question is, the convergence of the bisection method is linear, quadratic, exponential or logarithmic. So we have seen that the convergence of bisection is linear. That is the approximation we have taken as a straight line with the slope constant. Next question is, in LU decomposition, the matrix E is factorized into. There is a matrix given in case of LU decomposition, so we have to factorize the matrix. We factorize through diagonal as lower and upper matrix. So option A is correct for this question. What is the stopping criteria for iterative methods? We know that this is a way to find approximate solution. In approximation, how close we can get depends on the stopping criteria, where we have to stop the iteration method. So that depends on the number of iteration, like the example we did, where we say for bisection method we have taken number of iteration as third iteration, or the other stopping criteria is tolerance level. We remember we have got value as 2.5, 2.75, 2.625. So on the third iteration we stopped here. So we have taken the tolerance level as up to third decimal. We could also have taken this to be up to fifth decimal or sixth decimal. So number of iteration and tolerance level both are the stopping criteria for iterative methods. So option C is correct, A and B. Now in the next method we will see secant method, which is also called chord method. Secant is a iterative numerical method used to find approximate root of a non-linear algebraic equation. This method also needs two initial guesses, like the bisection x0 and x1, such that x0 should be less than x1. Now we will see with the help of graph. Suppose that we have this diagram as x and y, and we have this graph where this value is a and this value is b. Function value here at b is f of b. Function value at a is f of a. Now so we will draw a chord, and we will take this point here at this point as the next iterative value or the first iterative value, and from here we will again draw a next chord like this. Again we will notice that it cut the x-axis here is this point, so we will take this value as second iterative value. Similarly, like this we can draw more values, and we can see slowly we are moving towards the solution of the problem, towards this point. So that's how this method works. According to formula, xn plus 2 equal to xn f of xn plus 1 minus xn plus 1 f of xn divided by f of xn plus 1 minus f of xn. As of now, this formula may seems to be very complicated, but it is easy to apply. So now we will see what are the implications of this method. So first one is, no need to check f of a into f of b less than 0. So like in bisection or regular falsi, we check the product should be negative, but for this case the secant method we do not check this. This method will fail when the denominator term, means this one, equal to 0, then this value xn plus 2 will become infinity. So f of xn plus 1 should not be equal to f of xn. Sometimes solution may not converge due to poor guess. If we take poor guess, then convergence is not guaranteed in this method. Convergence is not ensured because the initial guess value we are taking is not lying on the both sides, means the product is not negative. The order of convergence for this method is 1.618, which is also called golden ratio. Now we will understand this method with the help of example. Solve for fx equal to x cube minus 2x square minus 5 equal to 0 using secant method up to third iteration. First of all, we will calculate the initial guess. We will check at 0. So f of x equal to 0, we will get 0 cube minus 2 into 0 square minus 5. So it will be minus 5. F of x equal to 1, we will get 1 cube minus 2 into 1 cube minus 5 equal to minus 6. F of x equal to 2, it will be 2 cube minus 2 into 2 square minus 5 equal to minus 5. F of x equal to 3, it will be 3 cube minus 2 into 3 square minus 5. So it will be 4. F of x equal to 4, it will be 4 cube minus 2 into 4 square minus 5. It will be 27. We can see that value of the function changing from negative to positive in this for x equal to 2 to x equal to 3. So to get the solution, we will take the value of initial guess as x naught equal to 2 and x1 equal to 3. And we have also ensured that x naught is less than x1. So now we will move to first iteration. So we will write the formula. The formula is xn plus 2 equal to xn. F of xn plus 1 minus xn plus 1 f of xn divided by f of xn plus 1 minus f of xn. To remember this formula, we have to notice that for the n plus 2, we will start from xn. For n plus 2, we will start with n. Similarly, if we want to calculate with xn plus 3, then we will write minus 2, that is xn plus 1. If we have to calculate n plus 4, then we will write xn plus 2 and rest of like this. Then after that, we can see this value and this value is directly put here. Now you can easily remember this formula. Now we will write the formula for the first iteration. For the first iteration, we will write the formula x2. So we will start with minus 2, that is x naught, f of by increasing 1 minus, then now changing x1, f of x naught, f of x1 minus f of x naught. We know the value of everything, so we will put x naught, that is first iteration guess is 2 into value of the fx1 4 minus value of x1 3 into value of fx naught, that is minus 5 divided by 4 minus and fx naught is minus 5. So it will be 2.5555. Now calculating the value of fx2, that is 2.555 to the cube minus 2 into 2.5555 minus 5, it comes to be minus 1.3713. For second iteration, now we have to determine the value of x3. So we will write minus 2, so it will be x1. Now we will substitute the value. x1 is 3 into fx2 is minus 1.3713 minus x2 is 2.5555 into fx1 is 4 divided by minus 1.3713 minus 4. So after calculating, it will be 2.669. and calculating the value of the function at this point x3 is f of 2.669. It will be 2.669 cube minus 2 into 2.669 minus 5. It will come minus 0.2343. Now we will calculate the third iteration. x4 we will write minus 2, that is x2 f of x3. We know the value of all this, so we will put x2 as 2.5555 into fx3 minus 0.2343 minus x3 we know 2.669 into fx2 minus 1.3713, so it will be minus 2343 minus 1.3713, so it will come 3.51. In the question we have to determine the value of x after third iteration. So this is the third iteration and this is the value after third iteration, 3.51. In GATE 2025 there may be one question from secant method. This may be a single directly from the secant method or in a combined form like MCQ or MSQ or match matrix. So now we will move to the next method, Newton-Raphson method. In short, this is also called NR method. Newton-Raphson method is a iterative numerical technique used to approximate the root of nonlinear function. Now we will understand the implications and the concept in short. It uses single guess value. Now we will draw a graph. Suppose that this is a function. The initial guess we have is x0. Then function value will be f(x0). Graph is fx. First of all, this will draw a tangent. Now this graph cut here on the x-axis. This is our first guess, x1. Now from this point it will go to here, and from the same curve, on the same curve it will again draw a tangent, something like that. Now again this will be our x2, the second iterative value. Again from this point it will draw a tangent here, and the tangent would be like this one. So it will now cut the value here, so x3 will be here, so next iterative value. Now we can see that earlier our guess was here on the x-axis, then it moves here, then it moves here, then it moves here and here in this direction. Now we can see the real roots is here. It cut the graph at this point, so and we are quickly moving to near to this point. So that's how Newton-Raphson method works like. The formula for calculating the next iterative value is x1 equal to x0 minus f of x0 divided by f dash of x0. This method has some implications. Let's discuss that. Order of convergence is 2. So this is also called quadratic convergence rate. There are few cases where this method fails. Now we will see all the 4 cases. So here is the first case. In the A figure, we can see that our desired solution is at this point indicated. And now this is the graph fx. And what happens? Suppose that our initial guess was any of this point. So suppose that our initial guess was this one. So from this point it will draw a tangent, it will move to this point, and now from here it will come here. Again this will draw a tangent, it will go here, and then the last they will go here, and again they will go here. From here it will come here, and again it will come here. First, second, third and fourth iteration it will continuously move on the outer path, so it will not converge. So this may be the one of the case where this method fails. In the B case, suppose that we have desired solution as this one. Now due to our initial guess, suppose that we have initial guess I is here, then it will converge to this solution, and clearly we can see that this fx has 3 solutions. So it will converge to only one of the 3 solutions. In the C case, where desired solution is this one, but it will keep moving in a loop. From this loop it will not exit, and we will not get any solution. Similarly, from the formula itself we can see that if this one, the denominator f dash x becomes 0, the solution is not defined. So it will always not define where the slope is equal to 0, where f dash x equal to 0. So it should not be 0 for real solution. Now we will move to the example part. There are sufficient number of examples. So we have these questions from GATE previous year. This question came in GATE 2010. Next question number 37 came in GATE 2022. This question 39 came in GATE 2019 for 2 marks. This question 37 number came in GATE MT 2021, and this question 27 came in GATE exam in 2016 for. So we will solve all of them. We will start with question number 27, the first one. So the question is, given the polynomial x cube minus 3x square plus 4x minus 2.5 equal to 0, starting from the guess value x equal to 0, what will be the value of x after iterating twice using the Newton-Raphson method? So function fx is equal to 0. First of all, we will find the f dash x, the first derivative. It will be 3x square minus 6x plus 4. For the first iteration, we will write the formula x1 equal to x naught minus f of x naught divided by f dash of x naught. We know the value of all, so we will substitute the value. We will get x naught 0 minus f of 0 by f dash of 0. It will be 0 minus, if we will put 0 in place of x in the function, we will get minus 2.5 divided by, and we will put 0 in the f dash x, we will get 4. After solving, we will get 0.625. We will determine f of x1, f of 0.625. It will be 0.625 cube minus 3 into 0.625 square plus 4 into 0.625 minus 2.5. After calculating, it will be minus 0.9277. Now calculating f dash x1, it will be f dash of 0.625 equal to 3 into 0.625 to the square minus 6 into 0.625 plus 4. So it will be 1.278. So it will become 1.421875. Now we will calculate for second iteration. Formula for second iteration, x2 will be x1 minus f of x1 divided by f dash of x1. After substituting the value 0.625 minus f of x1 we have calculated as minus 0.9277 divided by f dash of x1 we have calculated as 1.421875. So now it will become 1.278. After the second iteration, the value is 1.278. So this will be the answer. Option B is the correct answer for this question. Moving to the next question. This question is from GATE 2022. Which one of the following equation will fail to converge to a root with an initial guess x equal to 0.5 using the Newton-Raphson method? So it is asking which of the equation will fail to converge. So we will check the first condition, differentiating each of the function, and see if any of the function denominator is coming to be 0. So f dash of x equal to x minus x square, its differentiation will be 1 minus 2x, 1 minus 2x. So after putting f dash of 0.5, we will get 1 minus 2 into 0.5, it will be 0. So it's coming 0. So clearly Newton-Raphson method will fail for this equation. Now we will check for other three options also. F dash of x equal to e to the power x minus 6x. So f dash of 0.5, we will put the value, it will be e to the power 0.5 minus 6 into 0.5. So it's not coming to 0. So this will not fail. F dash x, it will be 1 minus 1 by 3x into 3. So it will be 1 minus 1 by x. After putting the values f dash 0.5, we will get 1 minus 1 by 0.5, that is minus 1. which is also not equal to 0. F dash x equal to sec square x minus 1. After putting the value f dash 0.5, we will get sec square 0.5 into 180 by pi minus 1. So this is also not equal to 0. Clearly we can see that in option A, the denominator is coming to 0. The formula is x1 equals to x naught minus f of x naught divided by f dash of x naught. So here in the denominator, the differentiation is coming to 0. So the whole x1 will become not defined. So it will fail to converge. So option A is correct. Moving to the next question. This question is from GATE 2016. Solve the equation x equal to e to the power minus x using Newton-Raphson method, starting with an initial guess value x naught equal to 0. The value of the x after the first iteration is. First of all, we will determine the function. So equation is x minus e to the power minus x. So we can write fx equals to x minus e to the power minus x. Then we will determine f dash x. It will be 1 minus e to the power minus x into minus 1. So it will be 1 plus e to the power minus x. Now we have to calculate the value for the first iteration at x naught equal to 0. So we will calculate f of x naught equal to 0. It will be 0 minus e to the power minus 0, which is minus 1, and f dash x naught equal to 0, we will get 1 plus e to the power minus 0. So it will be 1 plus 1, it will be 2. Now we will use the formula x1 equals to x naught minus f of x naught divided by f dash of x naught. On putting up the values, x naught as 0 minus f of x naught as minus 1 divided by f dash of x naught is 2. So the value is 1 by 2, which is 0.5. So 0.5 is the correct answer for this question. Now moving to the next question. This is a question from GATE 2019. The estimated value of the cube root of 37 obtained from the Newton-Raphson method after 2 iterations is. Start with an initial guess value of x naught equal to 1. The function given here is not direct but indirectly. First of all, we have to determine the function. According to question, the estimated value of the cube root of 37. Suppose that we have a value 37 and cube root is estimated as x. Then we can write this function in the form x cube equal to 37 or fx equal to x cube minus 37 equal to 0. Now we will determine the value of f dash x, which is 3x square, and we have to calculate f dash x at x equal to 1. So it will be 3. Value of the function fx at x equal to 1 is 1 cube minus 37. So it's minus 36. Now we will use the formula for calculating the first iteration x1 equal to x naught minus f of x naught divided by f dash of x naught. So it will be x naught we know 1 minus f of x naught is minus 36 and f dash x naught is 3. So it will be 1 plus 12 equal to 13. Now f of x1 is 13 cube minus 37. 2197 minus 37. It's coming to be 2160. F dash of x1 is 3x square. 3 into 13 square. 3 into 169. It's 507. Second iteration x2 equal to x1 minus f of x1 divided by f dash of x1. So it will be 13 minus 2160 divided by 507. So it will be 8.7396, approximately 8.74 up to 2 decimal. 8.74 is the correct answer for this question. Now moving to the next question. This question is from GATE MT 2021. Consider the function fx equal to x minus cos x. Using Newton-Raphson method, the estimated root of fx after the first iteration is. We have the initial guess as 0.5 radian. So we will write function fx equal to x minus cos x. After differentiating, we will get f dash x equal to 1 minus sin x. It will be 1 plus sin x. F of 0.5, we will get 0.5 minus cos 0.5 into 180 by pi. So we will get minus 0.37758. F dash 0.5, it will be 1 plus sine 0.5 into 180 by pi. After calculating, it will be 1.4794. First iteration, x1 equals to x0 minus f of x0 divided by f dash of x0. It will be x0 is 0.5 minus f of x0 is minus 0.37758 divided by f dash of x0 is 1.4794. So after calculating, we will get 0.755. So up to third decimal place after the first iteration, we have the value as 0.755 as the correct answer for this question. So with this, we conclude the video. Hopefully you understood the concept and the problem we went through. And now you will be able to solve all the questions based on linear and non-linear algebraic equation. Thank you.